I'm gonna continue. Maybe it'll be like an hour and a half. Maybe today an hour. I don't know. It's quite late in the night. But we have to stream. Make sure I'm live here. I can hear myself great. Listen, mute. All right. So I don't exactly remember. Just before I hopped on, I was trying to remember what we did yesterday. Let me get this setting here correct. Streaming is it's hard when you're streaming and learning because you're trying to manage like multiple things. But we keep going. Ghetto Bob followed me. Thanks for the follow. I just saw it, Ghetto. So if you're back here today, if you're watching, thank you very much. That's quite a funny name too, Ghetto. All right, so we continue. So today we're looking at where are we? So we did itemization. Yeah, this was a bit confusing because it involved multiple things. Yeah, I'm still not quite used to this part here, but I guess we'll just get more practice and we keep going. Let's see what I have. Okay. Okay. Don't want any of that. All right, cool. All right, we move on. Okay, what's next? So again, we're not doing any exercises. We'll come back to that later on. So I guess part 3 is when we actually implement this. Maybe I should try and do it because we've done the functions before, like 2 streams ago, like that. We did the definition yesterday, the type definition, and we also got the templates. Maybe we can just implement them. It shouldn't be that hard. And it's just a countdown too, right? Yeah, let's just try it. So I know he's got like a specific way he wants you to think through the problems. He wants you to solve using the recipes. Yeah, let's see. Let's see if I can remember or figure that part out. I should update the name of this too. Today is day 3. How do I stream? Edit info. There we go. Systematic this program. Design day 3. Okay. Done. All right. Okay, cool. All right. Let's see. Let's remind myself again. So countdown starter. It's a designing a system for controlling the New Year's Eve display. Design a data definition to represent the current state of the countdown, which falls into one of 3 categories. Not started, 10 to 1. That means it's before midnight or is complete. So not started, it can be a Boolean. 10 to 1 is any option between 1 and 10. And then complete is just a string. And we said this is atomic distinct and the type is false, natural, complete. Okay, so I guess we need, now that we have the definition, now we got to do the function thing, right? How to design function. So we need these things. Signature, we kind of already have the thing here. Yeah, maybe some check expects is where we start. So like purpose and stub. I don't know how to connect this that we did like stream 1. So we got the signature purpose stub, this thing into the data definition that we have, because it covers most of the similar stuff. Like that already covers. So number, countdown is Interpretation is false. Actually, maybe it doesn't. All right, let's try to define function for. I'm just gonna call it countdown. Take C. Condition. Yeah. I don't remember. I was gonna watch the video because I don't remember how where he led into this. So we move on. We just watch.
Now, because we previously saw how to construct a template for a mixed data itemization, and we saw that because there can be different data types in the itemization, we end up having to put a guard. For example, in the second case of the cond, we have the number question mark guard to make sure that we don't accidentally hand the string complete to this less than or equal to right here. Number question mark is making sure that this number isn't going to be the string complete. And we saw that in the last case we can just put else because it's the last case. You can always put else for the last case in itemization. But it turns out that you can simplify this template a little bit more. And here's why. Notice that there's only one case here of natural numbers. The middle case is natural numbers between 1 and 10. So it's because it's between 1 and 10 that we put the two less than or equal to calls. That gets us between 1 and 10. And it's because we want to be sure not to hand the string complete to that we put the number question mark guard. Because there's only one subcategory of numbers, it actually turns out that all we need is the number question mark guard. We can get rid of the and these two calls to less than or equal to and just simplify this second question in the template to number question mark. Because think about it, what this says is it says, well, if it's false, then that's the first case. And if it's a number, then that's the second case because there's only one subcategory that is numbers. So I don't need to bother to ask whether it's between 1 and 10. It's the only subcategory of numbers. And then there's only one case left for else. Here's one more example of the kinds of simplification we can do for the templates in mixed data itemization. I've got a data definition here which is supposed to represent the condition of a traffic light which is either disabled or it's red, yellow, green. And so in this data definition we used a mixed data itemization. False means disabled, and the strings red, yellow, green mean the color of light. So this is kind of an itemization that includes an enumeration in some sense, which is fine. That fits the definition of an itemization. Let's construct a template. So let's see. It's going to start out as one of 4 cases. And so that's a 4-case cond. The first case is atomic distinct false. So that question is now false question mark TL and ... And the next 3 cases are all atomic distincts and now they're strings. And I'll just fill them all in quickly. Now, because it's a mixed data itemization, then the rule is that we should guard these string equals. We have to say something like and string question mark TL, string equal TL to red. That would be the question, and ... would be the answer. And we would do that 3 times. So now that's good. We've guarded these string equals. But we could do something simpler here. Once we get to this red, there are no more data types left other than string. Everything from here on out is going to be some form of string. And so there's an additional rule, which is if all the remaining cases are the same data type, then you don't need the guards. That guard, and that guard, none of those have to be there. So we can take them back out. Like this, we'll take them out. And we end up with this simpler template. Now let's be clear. These simplifications of the template, they're not essential. The template we had 30 seconds ago was perfectly good. It worked. It would never have any problems. But this one is a little bit simpler. So there's 2...
Okay, so he's not actually writing the function in this part. Okay, that's fine.
If a given subclass is the last subclass of its type, which is what happened here, this natural 110 is the last subclass that's natural, we don't need the 110 part of the test. We can just have the guard. So we reduce that question to number question mark. The second rule is that if all the remaining cases are of a given type, then we can eliminate all the guards. So this just became the string equal, the string equal, the string equal.
I kind of feel like we should make a note of that. But I don't exactly know where. How to design data definitions, maybe somewhere here. If a given of its type, we can reduce the test to just the guard, i.e. number C. If all remaining sub classes are of the same type, then you don't need the guard, right? Then we can eliminate the okay, and this can probably actually go intervals, enumeration, itemization, probably somewhere here, because it is like mixed values. Okay. You still got a kick, that's fine. Alright. I think at this point I should probably do the things. I want to watch the last video and then just go through the problem book because my mind's kind of. I get it, but I don't get it. How to design functions. Is this interval? Interval's new, I think.
The next 3 videos are examples of designing a function that consumes non-primitive data, data that's defined by your own data definition. Now, they're HTTF problems, so mostly you know how to do them. Remember, I said the HTTF recipe is largely orthogonal to the form of data, but it isn't completely orthogonal to the form of data. One real dependence between function design and form of data has to do with the number of tests that's appropriate for that function. So in these videos, I'm going to pay particular attention to the number of tests that we're going to use based on the form of data. I'm in IL_racket, and the problem we're asked is to use the seatnum data definition and design a function that produces true if the given seat number is on the IL. So the first thing I would do is go look at the seatnum data definition, and it reminds me that seatnum is a natural number from 1 to 32 inclusive, and that its seat numbers in a row, and 1 and 32 are in the
Oh, we did this now. See, this one. 1 to 32, da da da. Yeah. Function for thingy. Templates used. Okay, so now here, he's gonna show how to use this to then go for the function recipe. Cool. This is like the first time kind of seeing it in action.
Who are the IL seats. So now I can get started on my function. I'll quickly do the signature purpose and stub. Let's see, it's going to consume a seat num, and we're supposed to produce true when the seat number is on the IL, so that means it's going to produce a boolean, and it'll produce false when the seat number is on the IL. And let's see, produce true if the given seat number is on the IL. And let's see, the function, this is a predicate, so we'll name it using the naming convention for predicates like this, IL question mark, well, the seat number is, and we'll just produce false for the stub. So let me run that to make sure the stub is well formed than it is. Okay, now let's get to the examples. Now here's the first place where the data definition is really going to have something to say. If we go back to the how to design data page, and we go to the section on intervals, and we go to the section on guidance on examples and tests, it tells us that when writing tests for functions operating on intervals, you should be sure to test closed boundaries as well as midpoints, and always be sure to include enough tests to check all other points of variance. So let's go back to the code. I've got an interval with 2 closed endpoints. So I know that what I'm going to need are 3 tests. One for the first closed endpoint, which is 1. One for the middle, which is, middle doesn't have to be the exact middle, something like the middle, call it 16. And one for the closed upper endpoint, which is 32. Now what are these going to be? Well, I'm supposed to produce true if the given seat number is on the IL. Let's see, this one is on the IL. This one is not, and this one is. Notice how much information the data definition gave me about generating the tests. Data definitions are always going to be helpful this way. They're not always going to make it quite this straightforward. But data definition, the structure of the data definition, the structure of the data tells us a lot about the tests we need. Let me run that. Good. They're all running. Now for the template, what I'm going to do is I'm first going to comment out the stub. I'm going to say use template from seatnum, and I'll just leave that note. I'll copy the template down, and I'll use it like that. I have to rename it.
Okay, this problem is kind of different. It's the same basis, but the function here is going to be. That's why I was a bit confused. This wasn't the same as before. Yeah, using the seatnum data definition, which is this one, we are going to design a function. Yeah, let's make a note of that. Design a function that produces if the given seat number is on the aisle. So it's either on the aisle or is it not? Alright, true or false.
Use template from seatnum, and I'll just leave that note. I'll copy the template down, and I'll use it like that. I have to rename it to the aisle, if that's the name of this function. And let's see, I'm consuming a seat number which is a natural from 1 to 32, and I need to produce true if it's an IL seat. That means I need to produce true if seat num is 1. Also, seat num is 32, and I just need to OR those two together. Let's try that. All 3 tests pass. So there you go. That's designing a function that consumes an interval. And the big piece of help we got from knowing this is an interval is, well, of course, we got the template, but we also got the structure of the tests.
I wasn't aware of this all syntax, but okay. Yeah, so following the how to design function recipe. So signature, it's going to take a number, and it's going to give a boolean. Number being the seed num, and it's going to either say true or false, because we want to basically say if it's yes or no to IL. Purpose, find if a specific seat is an IO seat, right? Stub. stub. Define. Go IO. 1 is true. Wait, stubs is like. Yeah, okay, it's fine. Examples, we sort of already have it here. So I think I can just copy that. But it's going to be IO. And we can go 1 is true. No, it's going to be 1 to 32. Oh man, 32 is. I don't know if I hate or love those parentheses just yet. It's confusing. Not confusing, but it's hard to know when the function or the thing stops. Anything else is gonna be false. This doesn't really make sense. So example / test. Template, we already have it from the data definition. I think that's what you're saying. Template copied from data definition. I'm just hoping like after doing, I don't know, 20 of these, I don't have to sort of think about these things. Why is that doing that? Okay, that's fine. Okay, so now the function itself. So we can copy that. I kind of remember he used that old syntax. So basically, IO seat number equals seat number equals 1, or seat number equals 12. And I think he did all like that. Like, I don't know how to. I think this is the indentation. Okay. Expected a variable, but found a number. Define. This is meant to be a test. So it's check expect. Check. Just copy paste it or whatever. Just type. Alright, so that should now pass. False differs from true. Okay. So this is returning true. Is that what it's saying? This is. Why? So if I do that and I just run IO 2, that's going to return a false. 392. What is this? What test is that? Oh, I thought this would comment up the test. Okay. Apparently not. Alright. So it is given a false. Define IO. Take seat number param if either equals 1 or equals 12. If it doesn't equal any of those, it should be false. So why am I getting the Is this wrong? Equals. I mean, it's just a number, right? It should be. I don't get it. Like, what's the problem? Define IO takes a seat number. It's either of these. I think I have some. This 1 or 12? Oh, it's meant to be 32, man. Why is it 12? Because the whole thing is 32 in the test. Oh, man, okay. Never mind. I just had a bad case of reading numbers. Okay, I should pass now. Yeah, cool. All right.
In this case, it's an interval with two.
And there's also these this rule. If it's a interval where you can have numbers from x, like 1 to whatever n, you want to have at least 3 tests for both edges and a value in the middle, right? That's what he said. Which is something that I didn't do in the test, and that's probably why I went wrong here. Trying to do my own thing. So this would be now be false. Sort of. Okay. Oh, what? 393. What did I do wrong now? Oh, this. Never mind. This should be true here. Because they're both IO. Okay, cool. Questions. Great. Man, it's been 20 minutes already. Okay, cool. Alright, let's move on.
We're looking at bump up starter.racket. And the problem here is to use the letter grade data definition below. Here it is.
I don't think we've done the bump up yet, have we? Bump. Or even the letter. Great. Oh, we did. Alright.
Here. And design a function that consumes a letter grade and produces the next highest letter grade. So we're going to call your function bump up. So here's the data definition that we did before.
Oh, it just bumps up. Okay, cool. So, design a function that takes a grade and returns a grade. Returns the next highest grade. Alright, let's try and just do this and then watch this video to see how close we got. So we need signature. What did he call it? Purpose. Stub. Examples. I think these were the things, right? Template. Templates. And then the function itself. Like. Okay, cool. So the signature would be. It takes a string and returns a string. I cannot type. It takes a string, returns a string. The purpose is produces the next highest grade. What will happen if if it's letter Z, for example, like if there was like that many grades unanswered? I guess if it's the highest you can have, then that's it. You can't go any higher. But then there's only actually it's an enumeration that there can only be A, B, or C. So if it's C, then it's going to be C, right? I think that's something that I have to decide here. So like, if C, then return C, because there is no higher. Well, I mean, actually, it's the other way around. If it's A, then higher goes backwards, not forwards. Right. So, the examples don't make sense. Does it make sense? Maybe actually it does in this case. Like check, expect. Okay, this is why you do the stub. For the stub would be next grade. Let's just go define next. I don't remember. Is it like this? I guess it's a dash because check expect has the next grade. That takes a grade, and then it returns another grade. Okay, this is where like I know what it should do, but it's just trying to fit it into the format that he wanted. I can't remember. Let's see. So this is an let's look at his definitions here. So it is an enumeration. Examples are redundant. So um, okay, so it'll be a cond. Actually, stop. We kind of have that here already. Uh, template from data definition above, but we'll just update the thing to say next grade, I guess. And if it okay, and then if it's a like, do we really want to hardcode this? I guess I don't know. Check. I mean, I don't know if I should have a test. Very simple test, I guess. Check expect. Next grade with an A. That just returns an A. That's just a rule I decided. I don't know if he's got a different rule for it. Because B is also an A, and then C becomes a B. Yeah, that's all the options, right? So the function becomes next grade, grade. Do I just return? I guess we could do or on this one. Might be simplify this. So I want to see the test pass, and then we'll simplify it. Make sure nothing breaks here. This function is not defined. Oh, okay, yeah, great. String equals. Okay, they work. So now this can be simplified. How? Like if it's C, return B. If it's B, return A. If it's A. Can we do or here? I mean, it's the same. Still be two lines. I'm curious, like how he's gonna solve it. So we're just gonna go with it. Let's watch the video. I think this is it. I'm not sure about the template part, or if he does anything for the stub. But using the data definition, this is how I would do it. Let's see.
Or, listen, I want to make an important point here. In these examples, we have a single data definition and a single function that goes with it. In normal programs, there tend to be many functions that consume data defined by a single data definition. So the ratio of functions to data definitions is usually pretty high. Don't think that you have to design a separate data definition for each function. In this case, there might be a function called bump up for the nice professors, and bump down for the not nice professors, and is honor roll, and all of those would all consume letter grade. There'd just be a single copy of the letter grade data definition. In fact, we put it in this part of the file called data definitions.
I should just
And then
call it
there'd be multiple
bump up.
functions down here.
Bump up.
So now let's get on with designing this function. And I'm going to do something here, which is I'm going to put a mistake in the template. And I'm doing this to show you why it is we're always careful to run templates when we do data definitions to make sure they're well formed. So I'm just going to inject that error right there, and we'll see what happens as we go on. Now try to forget it. So here we go. We're going to consume a letter grade, and we've got to produce the next highest letter grade. So we're also going to produce a letter grade. Produce next highest letter grade. Now there's an ambiguity in this problem statement, and we're going to start to have a little more ambiguity in our problem statements because remember, design is about going from ill-formed problems to well-structured solutions. And the ambiguity here is what do we do with A? Okay, there isn't anything higher than A.
Interesting that he's actually using the data definition. I guess we've defined, even though the type is string, it's better to use this because the definition mentions it's a string. Because it could have been like mixed values, right? Yeah, okay, so that is that. I think he's just about to cover what happens if it's an A. And I also like that he just used the thing from before, letter grade, instead of let's do bump up. Do like bump up. G letter grade, same thing.
So we might just put in parens, no change for A.
Okay, yeah.
Now we need a stub. We'll run that just to make sure everything's well formed.
Okay, so he does do a stub just for the single thing. Define bump up with a grade produces A. So this is just like it runs it, but like and then comment it out. Yeah. Okay.
Now remember, because this template's commented out, we're not seeing that error there. So now let's see. Here we go. Now we need examples. If you go to the How to Design Data page and you scroll down to the part about enumerations, it basically says that you need to have at least as many tests as there are cases in the enumeration, which is what makes sense. Going back to the code, this enumeration has 3 cases, A, B, and C. It makes sense that we're going to have 3 examples. Check expect of A. And we just decided that was
Okay, that's where I get messed up. So examples redundant is just for the data definitions, not for the function itself. The function, yeah, it does need tests. Best view stream.com. Who is that? How do I block this? Does it delete the message too? Show moderator action. Yeah, how do I don't know how to block this message. That's reply. I don't want to reply to him. I did it once, but I don't remember how. Quick action. Alright, if somebody wants to be a mod and deal with this, let me know, because I have no idea how to like delete this. Maybe I need to go in the actual like live chat. It's a little bit of delay, that's fine. Let's do that, let's do that. It's not there anymore, so I guess it doesn't show up. Alright, that's fine. Alright, let's move on.
I'll just copy this one and edit it because they're all going to look pretty close to the same. Let's see, there's bump up of A, there's bump up of B, and there's bump up of C. We already said that bump up of A produces A, bump up of B produces A, bump up of C produces B. So that's our examples. We'll run them to make sure they're well formed. And they are, but they're all running. One's not passing, we knew that. Okay, now we need a template. So I will comment out this stub. I'll say that we use template from letter grade. I'll go up here and get this template. I'll copy it down. I'll rename it. And now, well, this is quite simple, this function. If we are bumping up an A, we get an A. If we're bumping up a B, we get a B. And if we're bumping up a B, we get an A. And if we're bumping up a C, we get a B. And now I'll run it. Oh, and I'm getting this error. L, this variable is not defined. And Ragged highlights it for me. And now I have to figure out what this error is. And I see, oh yeah, this should have been LG because the parameter name is LG. So I'll put an LG there. And now you see, the reason I got this error is because the error was in the template. This is why we check the well-formedness of the templates before we comment them out, is to get as many errors as possible out of them. Because otherwise, every time you copy the template, you get the error copied, right? It's not good to copy code with mistakes in it. Back down here, let's run this. All 3 tests pass. So in this case, because we had an enumeration, we got not only the structure of the template, but we got the structure of the examples. Because for an enumeration, you should have at least 1 test for each case. In this case, it doesn't make sense to have any more than 3, but it is possible in certain cases for functions that consume more than just the enumeration to need more tests than there are a number of cases in the enumeration. We'll see examples of that in later weeks.
Okay, that's fine. So, yeah, I know what we did wrong. How did he get that rule for enumeration? Where was it defined? I know he went it somewhere here. Examples of, I think it's for function. How to design function from examples, function composition. Don't recall enumeration. It's permissible to use the thing. Guarded. Okay, this wasn't it. How to data definition. Here, maybe somewhere here. Forming the template. Okay. Guidance and yeah. Okay. Large enumeration. I should take some time to read this at some point. All specially handled cases must be tested in addition to one more test for the else clause. Oh, there is. There is. This is the part. So it should have at least as many tests as there are cases in the enumeration. I've never done that before. Okay. This is fine. All right. What's next? 1, 2. Itemization. So now we're gonna be doing the function for this one. Let's see if we can figure this out first. All right. So we know it's a wait, hang on. Make sure this is the one he's going to talk about. Let's see.
To string, we can turn
Oh, spoiler.
the problem in countdown to display starter.
Yeah, okay, this is the one. Okay, the problem is slightly different. So what's the problem? You are asked to yeah, I don't know how. Okay, you are asked to contribute. That's too long. What are we doing here? Okay, design a function that consumes countdown and produces an image showing the images. Okay, status of the count down. Okay, so it's gonna take countdown and produce an image. Image shows the state of the countdown, status and thing. What was it again? So we had signature. This is the purpose. The stub. I'm just gonna say define. I like having the thing in the next line. Okay, define countdown status is like countdown status that takes a countdown. It's gonna name it CD, and it produces an image. Okay, and then we got to decide. Yeah, we got to decide what a good image is. I guess purpose. Okay. Maybe this is where like red circle. Red circle means not started, because you can have false, in progress, or complete. Let's just go red, yellow, green, I guess. Yellow circle is in progress. Countdown is in progress, and then green means complete. Green circle. Okay, and then how do you do a circle? Define. I know there's a circle somewhere. Circle, solid red. Yeah, exactly. Okay. So, for example, it's going to be something like that. I don't know. Okay, so the template we can take from countdown data definition. We need some examples. Okay, so examples can be tricky because this is a mixed data type. Atomic distinct, atomic non-distinct. So we're gonna have to go through design function. Is this left one easy to navigate? I think so. Close that one. Okay, how design functions. Okay, so this is the first one is not started. It was just a boolean. Sorry, boolean. True or false? Okay. That is distinct. It is atomic. Simple atomic. Hang on. There's another box that goes over here. So atomic, distinct. Yeah, like true or false. The predicate is going to be. So we need a predicate. False question mark. Okay. Which you sort of have that already there. We kind of already. Right, let me just. Okay. So this is now going to be countdown status with the current count. Now the first one is if it's false. Here we want to draw false means. Okay. Yeah, I'm going straight into the implementation instead of writing the test. Oh man. Let's try it. Check expect count down status. If it's false, then we want this here, right? Yeah. I'm definitely not doing the order that they want me to do because I'm not asking myself like enumeration said that you need 3 tests, basically edge cases in the middle case. So for this one, like Boolean, where's the? I don't remember. Well, we'll see. Atomic non-distinct, like natural. Atomic non-distinct. Let's say like if it's 2. So I believe it needs to be like this here for this to work. It's one too many. Okay, cool. If it's 2, that means it's in progress, so it's just going to be yellow. And then the last one is like if it's complete. Countdown status is complete. It's just going to be green. If it's false, then here. If it's a number, and if the number's between 1 and 10, we want this guy. Otherwise, because the function can only take 3 types of params. If it's neither of those 2, then the last one has to be complete. So we can just say else there, right? So that should work. No. What did I miss? This is from a different problem. Line 450. Instead of expected value, bump up. This function is not defined. Okay. All right. Bump up. Where's bump up? Yeah, this one. Why is it not defined? Oh, next grade. Yeah. Define pop-up. Okay, cool. Did I not run it earlier? I don't know. Okay. So all of our tests pass here. That means this is fine. So like the question I have right now is using using like this atomic non-distinct and deciding okay how many test cases, because it's not, if it's an enumeration, it had testing defined let's see, forming a template, uh, um how to design functions, test and debug to correct, all right, simple atomic data, atomic fixed number of distinct items, forming a template, here. One or two data is usually sufficient for atomic data. One or two. Yeah, what if this is true? Falsening is not started. There is no true. Like it's either going to be. If it started, then it's just going to have 1 to 10. There's no true being sent anywhere. Okay. Okay. Let's see like how he did it.
Is to design a function that consumes the countdown type we defined earlier and produces a little image of the current state of the countdown. It might be something that would display on your phone if you were watching the New Year's Eve countdown. So again, the first step of the recipe is signature purpose stub. We can do that quickly. We're going to consume a countdown, and we're going to produce an image.
Mm-hmm.
And it's going to produce a nice image of current state of countdown. The stub is what we want to call the function countdown to image of a countdown. And the stub for functions that produce an image, I think it's kind of nice to make the stub just produce a blank image. And the way I make a blank image is I make a square of size 0. And it can be any color you want since it's of size 0, but I make it like that. So that's our stub. Let's run it. Where this function is not defined, this square right here. Oh, this is the bug about not saying require to HTTP image. If we go to the top of the file, sure enough, there's no require there. So we'll say require to HTTP/image. We'll run that. Okay, now we're okay. So this is a good example of why we check the well-formatness of stubs, and in general, why we want to run our code as often as we can. The sooner you find a little mistake, the easier it is to fix. It's easier to find one mistake now, and another mistake in a minute, and another mistake in a minute, than it is to find all 3 of them in 3 minutes. So run your code as often as you can is the general rule we're going to want to use. Okay, so now we need to do examples. The question is, how many examples do we need, and what should they be? So again, you can get some guidance for this by going to the How to Design Data page, going down to the section on itemizations, because this is an itemization, and the guidance here that says that there should be at least as many tests as there are cases in the itemization, and if there are intervals in the itemization, then there should be tests at all points of variance in the interval. Let's go back to the code and I'll show you what that means. Well, we know there's at least...
Okay, so this is what I missed. Instead of looking at like individual things, we're looking at well, it kind of is. So okay, let's read it. Let's read itemization here. So comprised of 2 more subclasses. At least one of them is not a distinct item. Yeah, in our case, the middle one, atomic non-distinct. From the template, guiding for tests. As always, itemization should have enough data. Yeah. Functions operating on itemization should have at least as many tests as there are cases. Yeah, so we got 3. And if there are intervals in itemization, then there should be tests at all points of variance in the interval. No, I mean, not in our case. Like, it doesn't matter if it's anything between 1 and 10 is just going to be in progress. So I don't know if we need like here, like over 30 means this, so we don't have any points of variance, right? Everything is the same, so I think it's okay.
There's at least 3 tests. Okay. So let's quickly do that. Check, expect, count down to image of some value. I'll just make 3 of these. We know there's at least 3. And let's see, the first one corresponds to this first case of the type comment, false, so that's false. So now let's see. What should countdown to image produce when the countdown isn't running? Because remember, the interpretation tells me that this means the countdown has not yet started. So if the countdown hasn't yet started, I don't know, there's lots of things we could produce. Let's just produce that blank image again. You could produce something fancier than this. The goal here is not to make the best possible version of this function, but to understand what the design of this function is about. That'll be the first case. And now we need a case for this interval. Now, we're supposed to test every point of variance in the interval. Conceivably, we could test with 1, somewhere in the middle, like 5 and 10. But in this particular function, the behavior doesn't meaningfully vary across the interval. Sure, we're going to display 1 and 1 and 10
no,
and
no
3,
variance.
but we're always going to display the number. So it's going to really be enough to have a single test for this interval, maybe at 5. Now the question is, what do we want to display? Well, let's see. We need an image. And there's a function called text, which can turn a string into an image. And there's a function called number to string that can turn a number into a string.
Okay.
So if we made a text of some size, now right now I'm just going to put the size of the text here. We'll see next week that the right thing to do is define a constant for this, but I'm just going to put the size right there. So what this is saying is it's saying if we count down to image of 5, we should produce the text of the number 5 in font size 24 that's black. And what are we going to do if the countdown is complete? Complete is the third case. Well, I say for that, we'll just say text of Happy New Year.
Okay.
And that will also be 24, but maybe it'll be some other color. Like
Yeah, mine's not as fun.
now,
Mine just shows red, yellow,
green.
green.
Using the concrete examples. So before I'm writing the actual code of the function, we did a lot of the designing of the behavior of this function. So that's the examples. Let's run them. Right, they all run, but some are failing. That means they're well formed. So now this was the stub. Let's comment it out. Let's put a note that says use template from countdown. Let's get that template. Copy it down here. And let's see.
What was his stub? His stub was define. Yeah, I mean similar. Okay, so I got that one sort of correct.
Rename it. Rename it, countdown image. So in the false case, well, this corresponds to this example, so that's just a blank image again. And this case is, let's see, we're going to convert C, whatever it is. This will just be text of, here's number to string of C, size 24 and black. And when cons get complicated like this, we tend to put the question and answer on separate lines. That makes the con easier to read. And then in this final case, that corresponds to this example, which is just text, Happy New Year 24, red. Let's see what's happening
Okay,
here.
yeah. So this is some syntax here, which I wasn't aware of. So I can't wait to get rid of this IDE too. Should be no, same line. And two cases go like this. No. Okay. Else that. Okay.
Right. Number to string. This function is not yet defined. I didn't get the error here though. Oh, right. The Dr. Racket version of this function is named with an arrow, like this. Okay, one of the tests didn't pass. Happy New Year differs from happy. Oh, I didn't put the exclamation marks in. Now let's try. I'll save it and run it, and all 3 tests passed. Notice I had to fix 2 bugs there. In each case, what I did was I read the warning message, or I read the failing test. I looked at the highlighted code, and I used that to give me an idea of what the problem was and how to fix it. The key thing about having bugs in the code is just to expect that that's part of it. Don't get upset about it. Don't worry about it. It happens all the time. It's just part of it. The very best programmers in the world have bugs in their code. Fixing it is part of designing a good program. And we're going to talk more as we go through the course about techniques for finding the bug as our programs get more and more sophisticated. Now again, notice that the data definition told us there were 3 cases. It's an itemization that includes an interval. That gave us the template. It also gave us the examples, and it helped us fill in the template for the function. A lot starts with the data definition. Let me show you one little side point here. We saw that Dr. Racket names its number to string function number arrow string. And we named our countdown to image function countdown to image. That's because this naming convention here is something you're not going to get away with in other programming languages. So I wanted you to see this naming convention too. But if you wanted to rename this function, let me show you a neat trick. What you're going to do is you're going to click on check syntax here. And now when I hover over countdown to image here, it shows me all the calls to it. But when I hover over one of these, it shows me the definition that defines it. Now what I'm going to do is on the Mac, I'm going to control click. On Windows, I right click. And I go to rename countdown to image. And I'll rename it up here using the other naming convention. And notice how it fixed all of them. But notice how it didn't fix the one that was in this comment. It only fixes the ones that aren't commented out. So now if you want to, you've got the function named the other way. This renaming command that I use is a thing called a refactoring. And it's very useful when programs start to get big to have tools like that for doing things like renaming. We'll talk more about that as we go on in the course.
Okay, yeah, that makes sense. So these questions, I don't. Okay, let's just watch through. I think we're almost done with module 2 here.
At the beginning of the week, I showed you this picture. And I talked about how the structure of this part of the course was really going to be defined by the cross product of recipes like how to design functions and how to design world programs with data definitions with different structure.
Yeah, that's really what we kind of accomplished today.
And then we designed one function using each of those data definitions. We basically completed the red box in this week. Next week, we'll do the green box. That point, that you can think about the organization of the first part of the course in terms of a cross product between the form of the data and the how to design functions recipe, that point's important. But there's a much more important point that underlies that. Think about the examples we've seen this week. think about the city name example and the best function. The inherent structure of the domain information in that case was atomic. So we represented it using simple atomic data. And that meant the template had a certain form, ... x. And that told us something about the function and something about the test as well. And that happened with all of the data definitions. With seatnum, the inherent structure of the information is a contiguous range of numbers. So in that case, we use an interval. That formed the template a certain way, it formed the body of the function a certain way, and it told us something about the test. In that case, that there should be 3 of them. Every example we saw this week, there was the same phenomena, which is that once we identify the structure of the information, the inherent structure of the information, that gives us the structure of the data used to represent it, which gives us the structure of the template, which gives us the structure of the function, and also we get guidance about the tests for that function. So identifying the structure of the information is really a key step in the program design, at least for many kinds of programs, the ones we're going to look at for the first 2 parts of this course. As data definitions get more sophisticated, what you're going to see is that there are different choices you can make about the data that you'll use to represent information. And by making different choices, you actually have a lot of influence on the rest of the program because of this fact that the structure of the data determines the structure of the template, determines the structure of the functions. So designing data is a very high point of leverage for designing programs. There are some programs for which that's less true, but for very many programs, this approach that we're taking in the first 2 parts of this course, this data-driven approach, does a very good job of producing the structure of large parts of the program. What we'll see later in the course is some examples where the control structure becomes dominant. And what we'll learn in that part of the course is how to blend templates based with control structure together with templates based on type comments or templates based on the form of data to produce the dominant structure of our program. But even in those programs, the form of the information determines the form of the data, and the form of the data determines the form of many of the functions that operate on the data. So identifying the form of the information remains a key step in designing programs.
Okay, so yeah, bad cop. Hey, what's up? It's been a while, man. How's it going? Yeah, I don't know why they let me in. I kind of slipped through, man. Somehow slipped past. How's things? Uh, it's like 1:30 a.m. I was actually about to go go to sleep because I was getting tired here. It's a bit of a late one today. I also kind of thinking. I don't know what that emoji is. Like, I am not familiar with Twitch. Whatever Twitch memes and stuff. I really think I should start doing some problem stuff now. Yeah, let's do that because it's gonna combine both of them, I think. And should be here somewhere. Practice problems, yeah. Rocket. So start with the rocket. Perfect. It also helps you do this. Yeah. Have you ever written any racket before? Any Lisp style code? These parentheses are doing my confusing me. Okay. All right. You know what's funny? I was looking at I was just watching the very first stream. There was a video on YouTube because I've got it all archived. And the Notion doc I used to have to track stuff, the top line said, "Get that bad cop money." Like it literally said that. I read that like 2 days ago. That's hilarious that you're here now. Yeah. Okay. Problem there. You're designing a program to track a rocket's journey as it descends 100 kilometers to the Earth. You're only interested in the descent from 100 to touchdown. Okay. So that kind of gives you the interval. Once the rocket has landed, it is done. That's okay. Design a data remaining descent. Okay. Right. And then I'm kind of gonna read through this and figure out. Okay. So I'm just gonna call it descent. DESCNT. Descent is it's an interval, so it can be it's between 0 to 100. Because zero is what's going to be done, I think. Right. Consistent numbers within range, so we need the interval. I think it's here. Yeah, count integer. Yeah, integer makes sense. Like that. Interpretation is the number. Is it kilometers? Yeah, number of kilometers left to reach off. 0 means landed. Okay. And then Actually, it just says start, middle, end. Okay. We do that instead. Define. It's going to get position 1, I guess. Position 1 is 100. Start. That could be start. Although, do we really care about the middle and the end? I think this is more. Interested in that. I guess it depends on this later. Let's not worry about that. Let's just do this and see if it changes at the end, and the end is going to be like 0. For intervals, that is the thing. Is that the thing? Let's see. Interval. Yeah, we need something like that in there. Okay, I'm getting more used to like his way of doing these. What's it called? Templates. Define functional count on CD. Okay. So in our case, it's less than or equal to. Oh, sorry, it's greater than or equal to 0. No. And less than or equal to 100, right? Yeah, that'll be the limits of the intervals. Let's go back. Oh man, where was it? How to design data for intervals, and then the templates. I think it's the same because it's just atomic non-distinct integers 0 to 100 in our case. Okay, so I think that's a good enough definition. And then the solution, the function, I guess. Design a function that will output the rocket's remaining descent distance in a short string that can be broadcast on Twitter. Okay. When descent is over, message should be the string. Call it function. Okay, it's quite specific in this one. So for a function, we need these things. Okay, signature. It's gonna take an integer, or really, it's gonna take descent, and it's gonna produce a string, right? It needs a short string. Purpose is tweet the status current, I guess current status of the rocket's descent. Stub define. I wanted to call it that. Let's say it's like 50. I spelled wrong. What do we have here? Actually, I'm just gonna go with the rocket has landed. Okay, and make that a 0. That's a nice case. Stub. Okay, now some examples. Okay, so check expect for intervals should be. Let's look at okay, interval. How many do we need? The 3 data examples above are probably more than is needed in this case. Yeah, okay, 3 is fine. Yeah, I guess we'll say 100 is started its descent. And we kind of defined it up top, right? Started. Yeah, let's do that. Let's descend middle. Get midway. Midpoint, I guess. Midway, midpoint. Office, descend, and then landed. Okay. Alright, so the template then is here. I'm still not sure if this is right, but yeah, I think this is correct. The function is going to be... Oh no, before we do the template, we need the check expects. I need some tests. And let's just say that this is a stub. Okay, so check expect. The function is rocket. Did I have a... Yeah. Come on. Okay, rocket. Intervals appear. Yeah, I think 3 is fine in this case because those are the only unique ones in our point. Other than that, oh, but like, what if it's like 49, something? Yeah, unless we divide like by 25s, and I don't really want to make it too complex. I just said just past. Past, it's yeah, let's do that. So that way we only worry about 3 cases. If there's anything after, even though if it's like 4, it won't be correct, but was designing like that. Whatever, like, it's fine for now. I'm curious how he's gonna do it, but in our case, 100 means this message. But he wants a short message, so this is not short. Started almost home. That's probably better, actually. Started its descent. Just gonna copy paste that twice. 50 is gonna be almost home. Question exclamation, and then kind of just wrote the code there. Landed. Function for countdown is gonna be that right there. Countdown. Okay, so in our case, I mean, oh, it's this .cd. No, where did I get this from? I got that from how to design functions interval, right? That's what I did. No. Here, interval. Number like cond. Oh, yeah, it is, and cond is if applicable. Okay, so yeah, it just did this here actually. Yeah, that should probably be the thing. I'm not sure when to use this and when to use. Oh, if it's a question that if it's the body, then I don't exactly remember what the body and the difference are. But okay, we'll continue. So so in that case, this okay. Number question mark because it is a number, and then this does need to be a condition. I think condition, and there's going to be 3 conditions. Right. So condition 1 is it a number? Oh man, these are number 100 means started its descent. Number 50. Almost. Man, I'm just like making the rules up as I go. Curious how he wants. Oh, how he does these things. Number no number no. Yeah, some all numbers. 0. Rocket has landed. Has landed. Alright, let's run that. What did I miss? Okay, I should pass. P1 is already defined before. Define P1, P2. Pause 1. Pause 1, pause 2, pause 3. Oh. Wrong buttons, man. Okay. Actual value is this, almost home. Okay, what? So we're getting the opposite. Did I do the test wrong? What did I? 100 means started its descent. 50 is almost home. What? Why? So expected almost home, but it got started its descent. Expected landed. Started to say, oh. Why would, okay, 0. Oh man, this isn't, we don't need a number, we need a, can't question. Yeah, I don't know. We just need an equals number. I think this. Yeah, because it was just like, hey, here's the numbers, and it was exiting early here, right? That's what was happening. Yeah, so I'm confused on these rules here. Okay, before the stream tomorrow, I'm gonna spend some time reading this talk because I don't know exactly what it's trying to do, but we have this. I don't know when that's applicable. Versus this, and also interval. Like, what? Okay, it passes. This is correct. So let's see his implementation. Actually, I don't think he talks through it. There should be a solution. Difficulty. Does he go through it? No, he does not. There's a quiz. We're not doing the quiz. All right, let's just look at the solution from the week 2 rocket solution. How close do we get? Descent. Oh man, I don't think we did any of that. Okay. So descent is an integer. Oh, it's one off. It's one off. Interesting. So it went with Okay, I mean, yeah, whatever. I just said if it's 0, that means it's done. It decided. It made it more complex, I guess, by adding 2 different types, true or false, and an interval. But in my case, it was just like 1. Type comment is also a reasonable solution. Why would you not why can't I just say 0? Like, Because that's a distance. I guess technically 0 is not a distance left. Okay. Yeah, I mean, I don't see why that would be a problem. So this will change how we do the solution here. So altitude, yeah, also makes sense. Condition and if it's a number, and you have to do this number thing. Now that it kind of makes sense where like these numbers here is to use within a condition. So within the condition, alright, okay, it's a condition question. Cool. So if you have a question within a condition, and if it's a number, then you use this predicate. Okay, it's making more sense. It means it's either this, it's this, and this. So it's between, it's greater than 0, less than or equal to 100, so between 1 and 100, and it's a number. Then altitude is, they got fancy, like it's this kilometers away. Like I just said, like it's on the way, uh, almost home. Like it was very lazy sort of solution, I guess, a lazy program design. But makes sense. Yeah. Okay. Cool. I'm happy with that. I get it. Yeah. I think I'm gonna call it a day here. I think with how long? We did an hour, 20 minutes almost. This is good enough. Yeah, we'll come back again tomorrow. Spend another hour, 2 hours, whatever, and then actually, I want to spend more time tomorrow. I want to get through. We've done 2 today. I'll spend some time reading this in detail. Maybe I'll do this problem before I before I come on tomorrow. And then the tomorrow's goal would be to finish module 3. So what do we have? We've done how to design functions, how to design data, how to design worlds. This is where should get fun. Oh, there's 2 parts, 3A and 3B. Reference. Yeah, okay, I don't remember this. So this is how far I got last time, like a year and a half ago, and I stopped. So if I can catch up to that by tomorrow, yeah, it'll be good. Tomorrow might be like 3 or 4 hour stream, but we will. Wait, tomorrow's New Year's. New Year's, right? That's fine. We're just gonna stream on New Year's. Why not? Okay, I don't know. Bad Cop, if you're still here. Thanks for popping in. I am gonna head out. So see you all tomorrow.